Example problems, and I'm going to change my ink color because I'm kind of tired of that one. I can classify real numbers. We're still talking about the same objective. This is actually in your book, page 16, and it's your turn. It's your turn 1 and 2. So if you want, you can try. All you're doing is classifying these numbers. So you're saying, are they real? Are they imaginary? If they're real, well, they're all going to be real. But where do they fall within the real round? Are they rational, irrational, etc. Okay, so a baseball pitcher has pitched for 12 and 2/3 innings. So we're looking at this number, and this is going to happen to you every time you go to a baseball game. You're going to sit down, and the person next to you is going to say, "Hey, the baseball pitcher has pitched for 12 and 2/3 innings, and is that rational or irrational? I mean, what kind of number is that?" Because I mean, it happens all the time at baseball games. I don't know if you've ever been to a baseball game, but that's exactly what happens. You sit down and they ask you to classify the number. So I'm going to give you some good practice with this. Okay, so next time you sit down, you'll be able to tell them, well, 12 and 2/3. Okay, so let's look at our different real numbers. So we're just going to start with irrational, because we can eliminate that pretty quickly. We have a whole number, which we know we can write as a ratio of two integers, and we have a fraction, which we can write, which is a ratio of two integers. So this is a rational number. It's not irrational. So we can skip the irrational part. It's not pi, it's not a repeating decimal, and it's not the square root of an imperfect square. So we know it's rational. So we can go ahead and write that down. We know it's rational. We're going to look at the rational side. If you want to look back at our box that has everything kind of together. So we're going to start at the very center. Is it a whole number? Well, no. We have a 12. That's a nice whole number, but the 2/3 is not a whole number. So it's not a whole number. So we move out to the next circle. Well, the next circle is integers, which are all whole numbers and they're negatives, and so it's not a negative whole number either because it's not a whole number. So we're going to move out from there, and then we're at rational numbers. So it is a rational number. We've already figured that out. And then we know that it's also a real number because they're all real numbers, except for the imaginary ones, which we're not going to talk about. This one is not quite so straightforward, I guess. We know that there's a square, so we'll start with that. Let's even draw a picture of, I draw such beautiful squares that I think we all deserve to see this. So the area of our square is 10 square yards. So 10 square yards is the area of the square. And if it's a square, all the sides are the same length, and that's what we talked about with square roots. Is if we take the square root of the area, it gives us the length of one side. Well, so we know that the square root of the area is the square root of 10. So we have this side is the square root of 10 yards, and this side would be the square root of 10 yards, and all the other ones would be the square root of 10 yards, which this is not a perfect square, right? It breaks down to 5 and 2. We don't have any pairs, so we can't break that out. So the square root of 10 is not a perfect square, which means that it is an irrational number. And if it's an irrational number, it's still a real number. So we're also going to classify it as a real number. And hopefully that example was helpful. I will go ahead and